In this section, we'll talk about simplifying what are called complex fractions. And what you want to think of when you hear the word complex fraction is just any fraction that has more than two levels. So instead of just a numerator and a denominator, it has fractions within the numerator or within the denominator or both. There is more than one way to simplify a complex fraction, but what we are going to talk about is the most efficient way to simplify a complex fraction. So these are the steps. First, you need to figure out what the least common denominator of all the fractions involved would be. Once you determine what that least common denominator would be, you multiply the numerator and denominator by that expression, and in one step you'll have everything reduced. So in this first example, the denominators are a times b, b squared, a, and b. So if we look for the least common denominator of those expressions, oh, sorry, I'm writing outside that window. If we look for the least common denominator of those things, we would need a factor of a, and we'd need two factors of b. So a b squared would be the least common denominator. So we're going to multiply by a times b squared in the numerator and in the denominator. So we're multiplying by a form of 1. So we're not changing the value, we're just changing the look of the expression. And you don't need to write all of this every time, but I will for the first time. So now we're distributing across that subtraction and across the addition. So we've got these four terms, each of which will be reduced. But that's what it would look like when we distribute that. If you want to write that step, if it helps, that's great. And then in the next line, we'll be able to simplify each of these fractions, and we shouldn't have any more complex fractions. So in the first group, we'll have a 4b left, and in the next, we'll have a 3a. And then we'll have a b squared, and then we'll have a 3ab. And then you should factor what's left if you can. There's nothing, the GCF in the numerator is just 1. In the denominator we could take out a b, but it's not going to allow us to simplify any further. So that's it. So we're done when we have just two levels left and when we know we can't factor and reduce what's left. Alright, next example. Before we look for the least common denominator, we want to make sure we factor the denominators that are here. So the denominators are x minus 3, x plus 3, and then x squared minus 9 would factor as x minus 3, x plus 3. And then the last one is our x minus 3. So, looking at those denominators, our LCD, doing that again. Our LCD would be just x plus 3 times x minus 3. So we'll multiply in the numerator and denominator by that group. Multiply by both factors in the numerator and both factors in the denominator, and then distribute. So again, I'll write all of the factors together, but if you want to skip this step, you can. Keep the 2 and the 3, but make sure you keep the subtraction between them. In the denominator, we've got a 5 times that group, and then a minus again, 2 times that group. And then in the next line, we'll be able to reduce things. we can reduce the x minus 3's here. So we've got 2 times x plus 3, keep the minus between, and then 3 times x minus 3. And in the denominator, that all drops out, so we have 5 minus 2 times the group x plus 3. Now notice we have a 2 times x plus 3 in the numerator and also a 2 times x plus 3 in the denominator, but it's not a factor, so we can't reduce right there. We need to distribute and expand. If we're careful there, that should be a plus 9. And a minus 6 in the denominator. If we regroup like terms, that's 12 minus x over negative 2x minus 1. And there's not really anything we can do to factor the numerator or the denominator. So that's our simplified form. Next example. The denominators we have this time are 4 minus x, x minus 4, which notice are just opposites of each other, x and x minus 4. So if we think about those denominators, the LCD would just be x minus 4 and x. So when we multiply the numerator and the denominator by those two factors, when we distribute, we'll have 2x and x minus 4 over 4 minus x plus 3x, x minus 4 over x minus 4. And then 1, which we can write or not, times x, x minus 4 over x, 5x, x minus 4 over x minus 4. And again, if you don't want to write that step, that's fine, but then you need to make sure that you get all the pieces right in the next step. These two, when we reduce them, make a negative 1 because they're opposite order subtraction. So that'll leave me with actually a negative 2x. And then we've got plus 3x over x minus 4 plus 5x. Combine like terms, that leaves me with x over 6x minus 4. And again, we could take a 2 out of the denominator, but beyond that, we can't really reduce anything. So either of these two expressions would be just fine. Next example. Just as in the last one, when we have x by itself, that's a factor, and x minus 1 has an x in it, but x is not a factor there. So our LCD would require both of those groups. Right, so it needs x by itself, and it needs x minus 1. So if we do x times x minus 1 in the numerator and in the denominator, we distribute, we'll have x, x minus 1, and another factor of x minus 1. Then we'll have x minus 2 and x minus 1. And the denominator will have x plus 2 and x minus 1. And x plus 1 and x plus 1. Oops. That should be an x minus 1 on the last one. Then we reduce where we can. We can get rid of those x's, we can get rid of those x minus 1's, get rid of those x's, get rid of those x minus 1's, and see what's left. So we've got x minus 1 squared plus x squared minus 2x over x plus 2 times x minus 1. Let's expand that. You know, let's just expand all of these here, because we're going to need to regroup our like terms. So x squared minus 2x plus 1 plus x squared minus 2x over, that would be x squared plus 2x minus x, so plus x minus 2 plus x squared plus x. Then if we regroup like terms, again we can't cancel here because we don't have factors, so we can't cancel these x squareds because they're terms, not factors. So we have 2x squared minus 4x plus 1 divided by 2x squared plus 2x minus 2. And then we try to factor where we can on that group. I believe the numerator is prime, so we can't factor the numerator. You could try different combinations. We're not going to get anywhere, but the denominator we could take out a 2. And then the group that's left is still prime, so we don't have anywhere to go there. So that would be our final answer. A few more examples. In each of these examples, what we have doesn't necessarily look like a complex fraction at the start, but once we rewrite it, it will. So because this x to the negative 1 is added with this 4, we can't just move this x up to the numerator. We have to do the reciprocal right in that position. So it would have to look like this, which then leads us to a complex fraction. So keep in mind there's like a 1 in the denominators where there's not a denominator written. So the LCD for this one would just be x, right? So we'll multiply by x up here and in the denominator, which is going to leave me with x squared over 1 plus 4x when I distribute the x in the denominator. And there's nothing we can factor or reduce there, so that's it. The next one, start the same way. We want to put 1 over x where we have x to the negative 1, and 1 over y where we have y to the negative 1. And then keep the denominator just like it is. If we want to write over 1, we can, just to remember that there's technically a fraction there. The LCD this time would just be x times y. So if we multiply by x times y, I'm going to do that on the left, this side, because I'm out of space, in the numerator and in the denominator, we will have xy over x plus xy over y, and then x squared y plus xy. Then we'll reduce as much as we can. Let's see, we can get rid of these x's and those y's. So we've got y plus x in the numerator, and in the denominator we could factor out an xy, and we'd be left with y plus 1. So we don't have any matching factors. We have a factor of xy in the denominator but not in the numerator. We have a factor of y plus 1 in the denominator but not in the numerator. So we have to just stop right there. Alright. In C, we have a couple new things. We have now some exponents that aren't just negative 1, and we also have coefficients in front of those exponents. So we need to be careful with that. So here we have multiplication. We can do 1 over x squared times y squared. We can make that a single fraction. And then in the denominator, this 5 has nothing to do with the exponent -1. So we would have 5 over x. And similarly, this 2 has nothing to do with the exponent -1. That's just on the y. So we would leave the 2 and the 5 in the numerator. And now if we look for our LCD, we would need an x squared and a y squared, which would have the y in it and the x in it. Right, so we'll multiply by x squared, y squared in the numerator and in the denominator. So multiplying by a form of 1, that will clear up the complex fractions in just one step. Now in the numerator we just have 1. In the denominator in the first group, the x will cancel, so we'll have 5xy squared. And in the second group, the y will cancel, so we'll have plus 2x squared y. And again, factor as much as you can. We can't really reduce this, but we could still say, well, we could factor out an xy from the denominator if we wanted to. Either of these answers is fine. The only reason to factor in the last step is just to make sure you can't reduce. But with a 1 in the numerator, you're not going to be able to reduce anything. Alright, last example. If we turn this into our complex fraction, we'd have 1 over a squared minus 1 over b squared. Then we'll have 1 over a plus 1 over b. Then we want to clean that up. The LCD would be a squared times b squared. So we'll multiply by that product in the numerator and the denominator. So we're going to be left with, in the first group, looks like b squared, keep the subtraction between, and then a squared in the second when the b's drop out. And in the denominator, one of the a's would cancel in the first term, so we'd have ab squared, keep the plus sign, then we'd have a squared b. This time when we factor, we'll actually be able to reduce this. So we've got b plus a times b minus a, because we have a difference of squares in the numerator. And then in the denominator we can factor out an ab, and we'd be left with b plus a. So we can reduce those, and our final answer should be b minus a over ab. But at that point there's nothing we can reduce because we don't have a factor of a or b in the numerator, we just have terms that are a and b. There is a mistake here in the video in section 7.7, the first problem, part B. Let's see, I'll show you where it was if you didn't catch it. Right here in the previous line, I should have had, I forgot to distribute the 2. So instead this should have been 2x plus 6 minus 3x plus 9 over 5 minus 2x minus 6, which instead of the answer I had before, we've got, it looks like 15 minus x over negative 1 minus 2x, or negative 2x minus 1. So there's the correct version of that one. There was also a mistake on the very end of this example on, let's see, what page is this? Page 3, part B. The very last thing I wrote down was a little bit off. Instead of what I wrote, that should be y plus x, and then the denominator factors as x times y times x plus 1 instead of x times y plus 1. So that's the correct version of that problem.